Hey, what's up, guys? This is Mr. Myesis. This is actually the morning. I don't often make videos in the morning, but it is in the morning right now. And so I'm not really just waking up because I'm obviously in my classroom, but got myself a cup of coffee and I'm ready to go. All right. So we're going to talk right now about L'Hopital's rule. L'Hopital's rule is a rule that we could use when we can't find, come on. I don't know why it does that. Okay. When we can't find limits, by just using direct substitution or using algebraic techniques. So it's kind of a nice little rule, nice trick to use when you got some sort of little complicated limit there that when you plug in using direct substitution, if you get 0 over 0, which is an indeterminate form, or infinity over infinity, either positive or negative, doesn't matter, those are indeterminate forms. We can use L'Hopital's rule, and you're going to love it. You're going to love L'Hopital's rule, all right? Here's the rule. Basically says that if the limit is going to be 0 over 0 or infinity over infinity or negative, positive, whatever, then you can just take the derivative of the numerator and the denominator separately, replug in that limit, and it should be equal to what your limit of the previous one's going to be, all right? That is L'Hopital's rule. Nice, okay? Let me show you a couple examples of this. So here, if I plugged in infinity for number 1, I'll get infinity over e to the infinity is infinity, right? So this is the form of infinity over infinity. So I can use L'Hopital's rule. So I'm going to use L'Hopital's rule, limit as x approaches infinity. I'm going to take the derivative of the numerator, which is 1, the derivative of the denominator separately, which is e to the x. Now I'm going to plug my infinity back in. I'm going to get 1 over infinity, which is the limit on that is 0. Easy as cake or pie or whatever you say, right? Easy, easy peasy. So let's take a look at the next one. So again, I got infinity over infinity. So I'm going to take my limit as x approaches infinity. I'm going to take the derivative of the top, the derivative of the bottom separately, and I'm going to plug back in, and I get infinity. Boom. Or you can write it as does not exist. I got all these examples, and you're going to think, oh, this is going to be so quick. All right, so the limit as x approaches 0. So I'm going to plug in first, direct substitution. I'm going to get 0 over e to the 0, which is actually 0 over 1, which is actually just 0. So actually, I didn't have to do L'Hopital's rule on that one. But we want to make, this is a key point, guys. We want to make sure that we plug in that value first to make sure that we use L'Hopital's rule. You can't use L'Hopital's rule if it doesn't give you an indeterminate form when you do direct substitution. That's very, very important, okay? So you got to always check. That should be your first line of defense, or that should be your first attempt anyway for any limit, is to plug in and see if it works. Why make it harder on you guys, right? Okay. So we're approaching from the left now. So I'm going to have e to the 0 from the left, and then 0 from the left. Let's think about what's going to happen here. This is going to be 1. These are going to be negative numbers, right? So these are going to be negative numbers. Negative close to 0, and 1 over a really, really, really small negative number is a outrageously large negative number. So this is going to go to negative infinity. So again, I didn't have to use L'Hopital's rule on that one. Let's check this one here. If I plug 0 in, I'm going to get 3 minus 3, which is 0 over 0. Okay, so now I'm going, yes, I can use L'Hopital. L'Hopital's rule. Let's take the derivative of the top. I get negative 9 e to the 3x. Don't forget your chain rule. Chain. All right. Derivative of the bottom is 1. Plug in 0. We get negative 9. Pretty sweet, huh? All right. We plug in negative infinity for this one. Oh, this one's a tricky one. We're going to get positive infinity. And e to the negative infinity is going to be, it's going to be like, e to the negative infinity is going to be a really, really small, that's going to be 0, right? Because it's getting small, it's 1 over e, right? Well, e to the infinity times 0 is indeterminate. This is another indeterminate form. And so we actually, for this case, we want to make it into one of those two forms that we have for L'Hopital's rule. So we're going to use a little trick here. when this happens, what we're going to do is we're going to move one of these to the bottom. Let's move the e to the x to the bottom, because we know that if we plug in a negative infinity, the negative times the negative is going to be a positive, right? So what's this going to give us now? We're going to have an infinity over e to the positive infinity, which is going to end up being positive infinity. So now we have the form that we needed to use L'Hopital's rule. So I'm going to use L'Hopital's rule now. Get 2x over negative e to the negative x. And we plug it in. I'm still going to get negative infinity over negative infinity. So I got to do L'Hopital's rule again. Believe it or not, you could just keep doing L'Hopital's rule until you get it to a place where it works. Okay, now we're at a place where it works, because we're going to get 2 over infinity, which is 0. All right, so we can just keep using L'Hopital's rule. Just keep doing it. All right, let's look at number 7. If we plugged in 1, we're actually gonna get infinity minus infinity, which again is one of those forms that we can't take infinity minus infinity. That's not really determinant. So I've got to do something to this to get it into my L'Hopital's rule form. We got 2 fractions here, so I'm gonna make a common denominator. So I'm gonna get x minus 1 minus ln x over ln x minus 1. Now what happens when we do that? We plug in 1 there, we're going to get 0 over 0. All right, perfect. So now we have 0 over 0 form, so we can use L'Hopital's rule. Take the derivative of the numerator, which is going to be, let's see, it's going to be 1 minus 1 over x. And the derivative of the denominator separately. Now we got ln x times 1x minus 1, so that is a product rule. So the derivative first times the second plus the derivative first times, well, I might have said that backwards, but basically same thing there, okay? All right. Okay, let's simplify this a little bit. Let's multiply the top and the bottom by x. Get rid of that fraction. See what happens there. We're going to get x minus 1 over x ln x plus x minus 1. Okay, what happens when we plug that in? We're going to get 0 on top, and well, we're going to get 0 on bottom again. Darn. Well, I guess what happens? We got to use L'Hopital's rule again. So let's just go. Let's just crank it out again here. Let's just use L'Hopital's rule. Limit as x approaches 1. It's going to give me derivatives. That's 1, and the derivative of the bottom is going to be. We just did that one. Oh, this one's different. Okay, so derivative first times ln x plus x times 1 over x plus the derivative of x is 1. Derivative of negative 1 is 0. All right, so let's see what we have here now. Limit as x approaches 1 of 1 over ln x plus 2, it looks like. All right, let's plug in 1 here. Ln of 1 is 0, so we end up with 1/2. So, we only had to do L'Hopital's rules twice, so it wasn't that bad. Let's take a look at 8. Now, this one says, let's do this without L'Hopital's rule. So how do we do it without L'Hopital's rule? Because when we plug in negative 1, we're going to get 0 over 0, right? So the first thing we always try to do is we try to factor. Okay? So we're always going to, that's going to be our first method that we try to do, is to factor this. And if factoring doesn't work, then we will we'll try L'Hopital's rule, okay? So we got negative 4 using factoring. Let's use L'Hopital's rule. Now, here's the thing, guys. If this is likely going to be a multiple choice problem usually for L'Hopital's rule. So if you think, oh, I could factor it, boom, you get the answer, but you look at it, it's 0 over 0, and you're like, you know what? Let me try L'Hopital's rule. It might be really, really fast. In fact, this is really, really fast. Look at the derivative of the top is 4x. The dir of the bottom is 1. Plug in -1, you got -4. Boom, done. Isn't that amazing? Yes, L'Hopital's rule rocks. Catch you guys later. Bye.